Let's take a look at lesson 1.3 that's talking strictly about the limits of composite functions. These are some tricky limits. The problem becomes in the limit of a composition is the composition of the limits provided the outside function is continuous at the limit of the inside function. We often see this as an if-then statement, but people will confuse it as a if and only if statement. That's where trouble comes. So f and g are functions where we have the limit at some target number c on our function is going to a real number, and the limit as our x value approaches that real number on the f of x, or the outside function, has to actually be the function value at that real number. If that's the case, then the limit at our target value can be thought of as moving the function f outside of the limit and taking the limit of the inside function and then evaluating the function at the limit. And here's another way to state it. The limit of a composition of f of g of x as x approaches c can be equal to the f of the limit of g of x as x approaches c, provided the limit as x approaches c of the inside function is a real number and the function is continuous when x goes to that limit value. We should notice this if-then statement requires certain conditions to be met. That's what our students don't understand. And problems occur when function f of x is not continuous at that real number, at that limit value, or the existence of the limit of the inside function at x equals a doesn't exist. When issues of this sort, we can't apply that property, this property up here, but we might assume that the limit doesn't exist. This may or may not be true, so we want to explore some alternative plan to find another approach. In this case, let's apply the if and only if definition of a limit. This is really key to understanding right here. So our students have to understand that the limit of a function from the left and the limit of a function from the right of any target number has to approach the same real number at that target value. So let's jump in with example 1. We want to find the limit as x approaches 1 of the f of x. So what I'm going to do first is I'm going to call u the limit as x approaches 1 of f of x. And I go over here and look at my diagram, and the limit as x approaches 1 from the left is going to -2, and as x approaches 1 from the right, it's going to -2. I also notice that as we approach 1, we're approaching values up here are bigger y values than -2. And approaching from the right, values up here, the y values are bigger than the limit from the right. So we can say that the limit as we approach 1 on f of x is heading to -2, but it's heading to -2 from values larger than -2. So we say that's from the right or from above. From above. And now if we go back to the function and take the limit as u approaches -2 from the right or from above, the limit at that value, let's go take a look, as we approach -2 from above, that's going to be from the right, the limit is approaching 4. So the limit of the composition, therefore, the limit as x approaches 1 of the f of x will be 4. In example 2, this is where it gets a little tricky. Again, I'm going to define my inside function as u, and we'll say let's let u be the limit as x approaches 0 of the inside function f of x. And then we're going to go take a look at our graph here. So if we notice in the picture that our if and only if, as we approach 0 from the left, we're approaching the value of 3, but we're approaching from the left, we're approaching from larger values, so from above. But as we approach 0 from the right, we're approaching from y values smaller than 3, so we're approaching from below. So we're approaching 3 from above and from below. That leads us to the fact that we need to use the definition of a limit. So for the limit as x approaches 3 from the left on our outside function evaluated at the inside value, that value has to be the same as the limit as x approaches 3 from above or from the right of f of u. So let's go look at the graph. As we approach 3 from the left, here's 3. As we approach 3 from the left, the limit is heading to 3. As we approach 3 from the right, the limit is approaching 1. Since the left limit and the right limit are not the same, then our general limit as x approaches 0 of the f of x composition does not exist. Our right limit and our left limit, we're approaching 2 different y values. For example 3, we're going to use the f of x graph up here, the g of x graph, and the h of x graph. For example 3, we want the limit as x approaches 1 of f of x. So let's define our inside function as the limit as x approaches 1 of the f of x. And let's look at the picture. So as we approach 1, here's 1. As we approach 1, our limit exists, and the limit value is -3. And we're approaching -3 from above, from the left and the right. The y values up here are bigger than -3, and our y values here are larger than -3. So we can say that our u substitution limit, we're approaching -3 from above, So we're going to use the note that it's -3 from the right. So to do the outside function, we want the limit as x approaches -3 from the right of the f of u. So as we approach -3, and again I'm going back to the graph, here's -3. As we approach -3 from the right, our limit is 2. And then we can say, therefore, the limit of our composition as x approaches 1 of the f of x is going to be 2. In example 4, we have the limit of h of g of x, and we'll have to go back and look at the 2 graphs as we get this set up. So let's define u is going to be the limit as x approaches 2 for g of x. And we want to go look at the graph at 2. So going back to the graph of g of x, that's our inside function. Oh, we have a major problem. So here's our first instance. As we approach 2, we don't have a general limit, so the limit on g of x does not exist at 2. But we can look at the left-hand limit. The left-hand limit is approaching 3 from below. And we can look at the right-hand limit, and the right-hand limit is approaching 1 from below. So back to our problem. we want to look at both cases. So where u value is going to approach 2 from the left, we said it was approaching 3 from below. So we'll say, make a note from below, so we have the notation. It's approaching 3 from the left, which was from below. And then I also want to consider that u is the limit as x approaches 2 from the right. So we have to check the left-hand limit and the right-hand limit on the g of x before we consider the outside function. And that limit was approaching 1 from below, so 1 from the left. Then going back to the composition with the h of x, I want to take the limit as u approaches 3 from the left of the h of u. We want to see what that value is. And I also want to consider the limit as u approaches 1 from the left on the h of u. So now we're going to go look at the h function. So the graph of h, as we approach 3 from the left, the y value is approaching 4. And as we approach 1 from the left, so 1 from the left, the y value is approaching 4. They're both approaching 4 from the left. What does that tell us? If this one approaches 4 and this one approaches 4, therefore the limit as x approaches 2 on the composition of h of g of x will exist, and that limit will be 4. Okay, example 5, let's go take a look at that. Here we want to define u is the limit as x approaches -1 on the inside function, that's h of x. We're going back to look at the graph of h of x. As we approach -1, here's -1. So as you approach -1, the limit is going to be -4, but notice we're approaching from the left above that value and from the right above that value. So we're approaching -4 from above in both the left and the right limit. So we're approaching -4 from above, and that's going to indicate the notation of the right in our composition. So the limit as u approaches -4 from above on the g function evaluated at u, back to the picture for g of x. So as we approach -4, here's -4, from above, that means from the right, our limit is approaching -3. So our limit will exist. It's approaching -3. Therefore, the limit as we approach -1 on the g of h of x composition will exist, and that limit will be -3. Now, a few more tricky ones. In this case, we have f of x on the left and g of x on the right, and we want the limit of the composition f of g of x as x goes to -3. So just like the first 5, we're going to say we'll let u equal the limit as x approaches -3 on the inside function g of x. Now g of x is over here, and as we approach -3, our limit or y value is approaching -4 from above, since the values are coming larger as we get closer to -3. Then the outside function, we want the limit as u approaches -4 from above of the f of u. So as we approach -4 from above, that's from the right, our limit is heading to -1. So since we have a valid limit Therefore, we can say that the limit as x approaches -3 on our composition f of g of x is going to go to -1. In example 7, we want to consider u is the limit as x goes to 2 on our inside function g of x. And back to the graph, we're looking at g of x as x approaches 2. In this case, as x approaches 2, our y value is approaching 4, but notice we're approaching 4 from y values smaller than 4. So we'll say that we're approaching 4 from below. Or, in our composition, that below is going to translate to the left. So the limit as our u value approaches 4 from the left on the f of u, and looking at the f function in the left, as we approach 4 from the left, our y value is approaching 3. Therefore, our limit as x approaches 2 on the f of g of x is approaching 3. So our composition has a limit. Then in our last two cases, these are the trickiest kind of all. When our limit goes to 2 from the right on the f of 8 minus x squared, I first want to consider what the graph of 8 minus x squared looks like. So if you think about the graph of 8 minus x squared, we've got an upside down parabola that shifted 8 units up, and we want the limit at 2. So by direct substitution, our limit at 2 is going to be the y value. So as x approaches 2 from the right, our y value is going to be approaching 4 from below. And I'm using 2 from the right because our limit notation says to do that, 2 from the right. Okay, so now in our composition, the limit as u approaches 4 from below, which is from the left, the f of u is going to be, now I got to go look at our graph. So we want to go look at the f function at 4 as we approach 4 from the left. So approaching 4 from the left, that's going to be this branch here. Our y value is approaching 3. So the limit is approaching 3, or the limit is 3 in that case. That tells us, therefore, the general limit as x approaches 2 from the right on the f of 8 minus x squared will be 3. And then finally, in our last one, we want to use the properties of limits first of all, since there's the g of 2 plus f of x. So let's think about this as the limit as x approaches -4 from the right of 2 plus the limit as x approaches -4 from the right of the f of x. Okay, so we're going to do the inside first, that portion first. So as we approach 2, that limit is going to be 2, since that's a constant function. And looking at the graph of f as we approach -4 from the right, so f as we approach -4 from the right, that's this piece here, as we approach -4 from the right, it's approaching -1. So that limit is -1. And 2 plus -1 is going to be 1. So our limit of that sum is going to be 1. Now we want to go back and look at the composition. So the limit as u approaches 1 on the g of u, so we want to go back and look at the g of x graph. As we approach 1, that limit is going to 2. So the trickiest kind of all is when there's other things going on in that inside function. Therefore, the limit as x approaches -4 from the right of the g of 2 plus f of x composition is going to be 2. And that, my friends, is some really tricky limits composite functions.